Now, if you were to send this picture to a friend, the compressed image would get brought back into the DRAM and then routed to the modem where it's divided and assembled into packets, then sent to the 4G, 5G, or Wi-Fi microchip, converted into electromagnetic waves, and sent to a cellular or Wi-Fi network. One thing we've talked a lot about is the movement of data through the SoC. All of this data movement between the blocks runs over connecting wires on what is part of the network on a chip. This network has routers and switches for shared access to routes and targets like the DRAM. The routers and switches arbitrate the flow of data and act like digital traffic lights, and the pathways act as a digital highway. These highways have different widths of wires based on what they're talking to and the amount of information that needs to be sent. Depending on required data rates, there are typically 128 or 256 wires running parallel to one another, carrying 1 bit at a time and operating between 500 and 1500 megahertz. In order to avoid wasting power from your smartphone's battery, the frequency and resulting data transfer rates across the network on a chip ramp up and down depending on the requirements of the applications you're running, and this feature is called dynamic frequency scaling. Before we explore the CPU and see